Okay, let's draw this diagram. So first of all, what this direction of gravitational acceleration? It is towards to the center of the Earth. Now on the block acting, what force is acting on the block? So gravitational force, which is acting like this, mg, and normal force, which is acting incline on the object, which will be vertical to the incline and the normal force. So first question we solve because it says just draw the all forces on the object. So the question number B, determine component of gravitational force acting parallel to the inclined plane. What we have to do in this kind of equations, how we are going to solve in general. First of all, you have to select the convenient x and y coordinate system. So for our convenience, let's select like this, x and y. Okay. Now, and then we write Newton's second law. Newton's second law is saying that force acting on the object, total net force, equal mass time acceleration. Now, in our particular case, Newton's second law, we have to write like this: normal force and plus gravitational force equal mass time acceleration vector. After that, you have to write projection on OX and projection on OY. In this particular case, projection on X will be projection of the all forces on this there, because this will be our X. That's what we selected. This will be our Y, right? So on OX, gravitational force projection on OX will be this force. This will be mgx. And this angle will be theta because this small right angle triangle and this big right angle triangle are similar. So in this case, the projection on OX will be n. The force of normal force projection on OX will be 0 plus gravitational force on projection on AOX, which will be parallel to the inclined plane. It's mg sine theta. So this will be equal 0 because, sorry, not 0. This will be equal mass time acceleration on x direction. From here we can find the acceleration, which is equal g sine theta. So here we plug numbers, we will get 4.9 meter per second square. In OY direction, it will be n minus mg cosine theta equal m time, no acceleration on y direction, right? So this will be the angle again. So this will be mg y component. From here, normal force will be equal mg cosine theta. And if we plug numbers, what we will have? We will have 21.21 Newton. So the mgx component, mgx, as we said, this force asking parallel force of gravitational force parallel to incline. It is mg sine theta. If you plug numbers, you will just get 12.25 Newton. So this is the answer of the question B. This is the answer of question C. And lastly, we have to answer number E. So with what will be the its bit at the bottom. So it's easy. Here we can use a couple of different ways, but easiest way to use conservation of energy, mechanical energy. So this is, let's say this height is h, all this distance is given d. So if we write conservation of energy, what will be? It will be mgh, because in the beginning object has potential energy, our potential a zero level, we are considered this, that's why it has in this level it has gravitational potential energy, which will be equal in the end, when block reach in the end, it will have only kinetic energy. So note that in the beginning, when the block was in this position, initial speed is zero. From here it is easy to find v, which will be equal square root 2gh. Of course h you can find from this right angle triangle, because sine theta, you know, here sine theta will be equal h divided d. From here h will be equal d times sine theta, and then if we plug h here, what you will find, you will find that v equals square root 2g d sine theta. If you plug all numbers, you will get 4.2 meter per second. And this will be the answer of the last question, which is E. So the problem is solved. Thank you so much.